Okay, we're going live. I think this should come in now. Yeah, I think there's just there's quite a delay. I can see myself in real time here and see myself over here. Way, way delayed. Um, Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, and welcome to our Thursday live stream. Now, note that we have had the time change here in Colorado. It is now daylight savings time in the United States. A lot of Europe will not go to summertime for a while yet. So this is 0045 UTC tomorrow. So this is that little period of time where you may need to make a few adjustments in order to see this live. Of course, this is all recorded and put up and available. By the way, I do not monetize these live streams because I just don't. I had heard from people that the playbacks were just absolutely full of interruptions with commercials, and I hate that. So I won't inflict it on you. I suppose I could make more money, but I don't want to do it that way. Not by making something that's just plain unpleasant to watch with all those commercials. Okay, it is 30 degrees Fahrenheit and 84% relative humidity. So the dew point is 26. So if the humidity rises any more, we could be looking at fog. We do get a little of that this time of year. We're near a lake, and if it gets cold, really cold, the water, of course, is much warmer, and the fog just rises up off the lake, sometimes comes our way. We've got a fence in our backyard that's about 75 feet away, and on the other side is a couple acres of meadow, and then there are trees on the other side of that. The fog can get so thick that you can't see those trees back there. And I've been in really thick fog on the roadways here. Thick fog is a common problem on US Highway 6 as you go from Green River to Price. And I've run into fog in other places too. It seems strange to see fog in the desert, but it can certainly happen. So as far as what's happening, I'm getting absolutely inundated with stuff to review. This is a radio. They sent me one to review and one to give away. Well, I've got so many handhelds sitting around, I will probably give both away. First glance at it today is good. I used my old red programming cable that I got from PowerWorks ages and ages and ages ago for the KE0OG radios. In fact, the logo on this thing is KE0OG, Wuxun. That's the logo on it. And I got this from PowerWorks. And this is sort of a universal cable that seems to program anything that this end will fit into. This is the Kenwood style cable. Now, the programming software is different, but this kind of cable right here seems to work really well for programming things. I had to really search for the software for the thing, because this is a radio that's apparently being newly released by Quansheng. And it looks an awful lot like a UV5R. So, but it has a bunch of other things on it. It has 10 memories for your favorite local FM stations to listen to. It's 200 memories for ham radio frequencies. Also has some, when you're in the VFO mode and you push buttons, it will bring up some standard frequencies that you might like to punch in fairly often that you can set up. They claim this thing will receive AM aircraft band. We'll see. They also claim that the ones that are marked for FCC, meeting the FCC regulations, will only work in the US ham bans, or if sold in Europe, only work in the European ham bans. But I'm going to test that and see if that's really true. So we'll also test it on the spectrum analyzer for spurious emissions and stuff like that. So we'll give it a good thorough test. It's only a 5-watt radio, which actually is what all the radios were 20 years ago. They started going up and up and up, which means they deplete the battery faster and faster. But, you know, as with so many things in VHF or UHF, you're either into the repeater or not. So if you were to use this in a car, I'd put a antenna on the roof of the car. In my Jeep, I'd put the antenna actually on the hood, because that's metal. Bonnet, for those of you in England. So we'll see. I also got a very interesting J-pole assembly from a patron who had developed this thing himself. And it's got a unique form of feeding it. So we'll take a look at that too over the coming days. There's just stuff piled up everywhere. Kai Wheats sent me this wire stripper. What's really cool about this is that it'll strip more than one wire at once if they're all the same size. And also something I've never seen before, little wire terminals that will go into something. There, if you can see up there, they've got little pieces sticking out that turns into a square after it's squished. And you can put them into these type of little connectors right here. Now what I had to do was to tin these leads to get the screws to clamp onto them. But apparently what most people do around the world is they put these little tips onto them so they can put them in and screw down on them. It's, I guess the nearest you can explain it, it's like on shoelaces, you've got the little end that's wrapped so it doesn't fray. And it's kind of like what these do for wires. So I have to admit, I've never seen it before. So we'll take a look at it and see what's going on with that. Oh man, that's just piled up quite high. I've been going through my email, and I am down to 19 emails in my inbox. When I started this project, I had well over 100. And I'm very sorry to those to whom I replied so late. I mean, there were emails in there from December that had not been replied to. I think I've got just about everybody now, getting up pretty good. Well, let's see what people have to say on this beautiful Thursday evening. Lefty says, hi, Dave and fellow Augies. Expecting snow here in Waterloo, Iowa tonight. Iowa. Don Zed, hello from Minnesota. Lieutenant Colonel Nicholson, EMP Shield sells several devices, one north of 700, supposed to protect electronic equipment from an EMP. What are they? They're just a Faraday cage. You could wrap it in tinfoil and do the same thing. $700 seems like a lot. Also, ferrite beads. How do they protect against EMP? I have gotten enough questions recently considering EMP. And that I think I'm going to do a video about it. All of the actual data that we have concerning EMP comes from a series of nuclear tests that were done in the late 1950s by lofting weapons into space and blowing them off. And they knew there would be an EMP, but they didn't realize how large it would be. And when the instrumentation readings came back that it was enormous, they basically said, oh, that must be bad data. And they finally looked at it again and so on and came up with some good data. But even if you take, and I've got a fairly recent FEMA report, FEMA or Department of Homeland, I think DHS report on what to do for EMP. And I looked up, I dug through there, I said, where are they getting the data on what the EMP looks like? And it goes all the way back to those tests in the 1950s. So we are using 70-year-old data taken with 70-year-old test equipment, and we're trying to base this whole story on EMP. Apparently on EMP there are two pulses of interest and a third one that's not of interest. The first pulse is extremely rapid, nanosecond or so. It's DC to daylight, so it puts out a very, very, very broad spectrum of electromagnetic noise. Now, how much is in a hertz slice, you know, what's in the bandwidth of your receiver, I don't know. And that's what I'm going to look up. Now, the second pulse that follows after that is very much like lightning. Okay, so if you have your lightning arresters and your spark tubes and all of that kind of stuff, you've got the second one covered. Now, the third one is a very long, drawn-out pulse that would have no effect on an average ham station, but for somebody who has long electrical lines, like the grid, electricity, and so on, this is of major concern because it can develop a voltage that will cause problems at stations. Now, in the average substation, there are a lot of protections that didn't used to be there in the 50s, but there are a lot of protections as far as tripping and so on. They can do it very quickly. There's some relay devices in there that they think might burn out. As near as I can tell from the latest I've found, they don't think they'd actually kill the transformers. The protective circuits on the transformers would drop it, would drop the load. And they've got, you know, to break a circuit at that high a voltage, you almost have to fire the pieces away from each other to keep it from forming an arc. And that arc will cause the electricity to keep on flowing. Arcs actually have low resistance and a pretty low voltage across them. And however, they can have extremely high current. So it's that E1 pulse I'm going to do some more research on. Now, the electrical energy, like I said, is spread from 0 hertz up to several, probably into the not terahertz, which one below the giga, mega giga. It's in the gigahertz range, so it's up into the microwave. And it's a very brief pulse. Now, the thing is that we deal with frequency-sensitive devices here. So the part of that pulse, the energy is spread across the entire pulse. The part of that pulse that reaches our equipment is limited by things like roofing factors and roofing filters and so on and so forth. And that's what I'm going to try and find out, is basically the dB hertz of that E1 pulse. Now, the other thing, and I saw a video on this done by a guy I really respect, who does a marvelous job, but he did not address the elephant in the room. The elephant in the room is, where is this pulse coming from? Anybody who says that our own government would put a nuclear weapon in space and detonate it is nuts. Totally nuts. And I give that theory less than zero credence. It would have to be put up by somebody, basically Russia, who would still have the weapons to do it. The Chinese, I don't know if they're going to try something like that, because the problem is that EMP, if it goes off early, and the thing is that the EMP is reflected by the ionosphere, so that could come back around and bite them. And so the chances of them doing that are low. I think the big original worry was about the Soviet Union or Russia now. Ukraine was part of the Soviet Union, but it's certainly not part of Russia, despite what some people say. So the chances that we will see an EMP event in our lifetime are about 0. Now, the kind of solar flare that could cause trouble with long lines hits the so-called E3 pulse kind of thing. It's elongated and has very low frequency. Well, a 50 hertz or 60 hertz grid is very low frequency. And you look at the extent of the grid, and it actually makes for a very nice antenna for those signals. So we could get that from a solar flare. We had the problem in the past of a solar flare knocking out Hydro-Quebec. That was some years ago. And they put more protective circuits in there. The solar flare does not create that kind of DC to daylight pulse. It wouldn't hit that. It just is not there. It's not part of the spectrum. So if you want to protect against EMP, if you believe, for whatever reason, that there will be an EMP pulse, which I do not. I do not. I would at a minimum make sure your station is protected for lightning. Okay, that means best practices on lightning arresters. I happen to like the Alpha Delta products best. You've got a ground rod right outside your shack. Your cable comes from your antenna to a lightning arrestor that is bonded really well to that ground rod and then comes into the house. That gives you some lightning protection. Another thing you can do is, like my switches in here are also Alpha Delta. And when they're in they call it the common, but it's off. All the other inputs are shorted out and shorted to ground. Okay, and then of course you ground the switch and so on. You have your station ground and everything like that. You're pretty well protected right there. Now, of course, in the event of a direct strike, all bets are off. Simply disconnecting your equipment entirely, your transceiver, and just setting it on a table on the other side of the room will definitely protect the radio from a direct lightning strike. I know because I've been through it. I had my radio completely disconnect. We got zapped directly. It caused some other damage. The neighbor across the street saw it happen. He saw it vaporize my 20-meter dipole. Now, it's that first pulse that might affect something that's metal. I mean, putting it in, you get those down at like Costco, those bags that pizza delivery guys use. They're foil on the inside. And you put that in there and zip that up, you got pretty good protection for cheap. Like I said, I'm going to research that E1 wave and see what it might do if it did it. And again, I state that anyone who detonates a bomb in the near space, in the ionosphere, risks biting themselves really badly, because it would destroy satellites, not just near that, but for thousands of miles away around the Earth. Remember, the Earth acts, between the Earth and the ionosphere acts as a waveguide. And so anybody who throws one of those off is damaging themselves pretty badly too. So I think the chance for an EMP pulse is 0. But enough people are concerned about it. I'm going to research that A1 pulse and see what can be done about it. As far as A1, E1 pulse, the E2 pulse is just like lightning. The E3 pulse is only of interest to the utilities. Okay, so it's that E1 where we have an extraordinarily short pulse. DC to daylight, extreme broadband noise. And the question is if there's enough power in a given slice to do anything, plus the pulse is so short, nanosecond or so, that it's going to have, the power to the electronic devices is if you raise the voltage, the stuff starts to break down, but the pulse lasts so short that it can't really get to the point to break it down. So anyway, there's a little top level thing on EMP. Let's see. How to protect against EMP. I like what Ham Radio Crash Course said. He said, just get a metal garbage can with a lid. That would do it. I ground that, by the way. Okay, good evening, Dave and all Augies worldwide from Chuck Schreiber and 5 KVO from South Texas. Currently 75 stormy front heading our way, dropping to upper 30s in the morning. Yeah, there was, we had snow here this morning. Another couple inches or so, but it melted off pretty fast. Oh, it's down to 29 degrees now, so. Okay, Larry Fields. It says, good morning from DU1. I guess there's a slash in there. Excuse me. DU1 at 6HPX. So that's an American in Germany, and it would be morning there. It'd be about 2 in the morning there. Anthony Becerra, evening Dave. Jay Langley in for NRL. Hi Dave, good to see you. E. Hayes, hello. From no. Oh, it kind of mushes together. I'm sorry. In Tennessee. Daryl Troutman, KN4ZIR. Hello from Kentucky. Golf Zero. Foxtrot Victor Tango here in the UK. We are at UTC right now. Okay, so it's 1 in the morning for you guys. You guys are really loyal to come on at this time of the night. By midnight here, local time, I'm completely out. So, Brian Lovelace says, greetings from Texas, KI5LOV. Optical Man Jeff, hi Dave and all Augies from Sioux Fall, South Dakota, where it's 25 degrees. Mike Oswald, hello Dave and all Augies. AA7MO reporting in from Middleburg, Florida. The dinner is done, the dishes washed, and here we are. Very good. Lefty, Mike Oswald, what's the weather like in Middleburg now? Oops. Okay, it says 63, clear skies and calm. Last night, 40 degrees. Phil, KA2QIK, hello from rainy Kalamazoo, Michigan. Lefty Ty Mike. Thank you, Mike, I think is what that is. Robert Keister, hello from North Texas, WZ5E. Gerald Troutman, KN4ZIR. David, they are called wire ferrules. Oh, yes, ferrules. The word doesn't actually appear on here on the box. There's a million of them in here. It says 1,200 pieces of all shapes and sizes, going from number 10 wire down to like number 22 AWG up to 7 AWG. Okay, these are cool. I have opened the box, And of course, immediately a bunch of them jump out onto the desk. But I'm going to try them and get a video on that because they're cold. They're ferrules. Ralph KI5NUK, another howdy from North Texas. Russell K4QPR, hi Dave. Tip of the shoelace is an aglet. Okay. Here, I was thinking it was always the thing that came off. But that's what they kind of do for this. Matt Katz, RC and Electronics. Hi Dave, Matt, N6FPV here. I have a follow-up video and info I'm emailing you very soon about the Nano VNA and SWR. Yesterday I did my commentariat for the week. And we got onto the subject of the Nano VNA. And there were enough people defending the Nano VNA that I'm going to take a second look. Okay? I'm going to take a second look. And I got a video from N6 FPV, first person view. And he taught me how to get the screen down to where it was just SWR. But he's going to send me another video that shows me how to set the lower frequency limit and the upper frequency limit. Because I, for the life of me, could not figure out how to do it. I have this little drawing pen. It's used for drawing on the iPad. And this tip right here is sensitive. The iPad senses that. So I've been using this thing to touch the very tiny little menu that's on the screen of that. Also, there was somebody who told me that there is the group that originally came up with the idea for the Nano VNA. And of course, there are a million clones. And what he was telling me is there is this group, and they have a list of approved vendors. And I want to get one from one of the approved vendors and get the most recent software for it or firmware for it. I mean, they're so cheap. If there was some simple way, if I could come up with just a simple one piece of paper in big print, 14-point type, do this, 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 and measure your SWR. That would be wonderful and would solve for a lot of people the problem of antenna analyzers. Okay, Brian Mills, Dave, I'm looking for my first HF antenna, looking at end-fed half-wave. It works. Very few seem to be waterproof. Take a look at the My Antennas one. Also, the one from the League, I think, might fit that character too. Now, if you're in Florida, what I would do, I mean, there's a gasket around that thing, but because of the heating and cooling cycle, when it gets hot, the box expels air. When it gets cool, it sucks air in. Now, that air it sucks in is more humid than the air it pushed out, so eventually you get condensation in those things. And that's a real issue. We had that issue when I was in the Air Force with our radar, our height finder radar. And we just drilled a little 1/8-inch hole in the bottom. And that allowed the pressure to go in and out of that very easily. And the next time we looked inside a few months later, dry as a bone. So you can do that with any of these. I would suggest the My Antennas end-fed half waves because I've tested them and they work wonderfully. And I like the way they're built, good solid build and so on and so forth. So there are a lot that are just the exposed coil. I'd put some sort of waterproofing around that. The toroids are waterproof, so's the wire. But still, it's nice to have that sort of stuff sheltered. Okay, Warren Baker. Hi, Dave, 59 and clear in Chattanooga, WA4BAK. Aglet, name of the tip on the end of the shoelaces. There, I've gone my whole life and didn't know that. Wow. People are discovering all kinds of things I don't know. Eric Sund, hello, Dave and fellow hams. Missed last week's live stream, nearly lost it anyway. Well, I'm glad you found it. Wade Clark, hello. John Hummel Newell, Victor Echo 5. Juliet Hotel Nancy, hello, Dave and all the Yogis. Canis Majoris, 76, agree. W4CWL. Eric Sund, a local ham, rudely told NHT user that his beep after the transmission is non-compliant. Is this true? No, absolutely not. But it's not best practice, okay? A lot of repeaters, when you let up on the mic, you get a squelch tail, and then there will be a beep. And that beep indicates that the squelch tail is over. The best practice way of operating on a handheld, just happen to have one right here, is to transmit, let up on the push to talk. Everybody waits for the repeater to beep. And when the repeater beeps, that's when the other person starts their transmission. Now, why? The reason for that is so that somebody can interrupt. And I have had a time when I was in a kind of emergency situation and I could not get in a bloody word edgewise on the repeater to get help. And we were up in the mountains, and the only repeater that I could get to was the one connected to the system up in Grand Junction where they can give help. But I mean, they were right in after everybody else, and my signal being in the mountains wasn't that strong. So, therefore, best practice, leave a little space, a couple seconds, after you key up. Not all repeaters have beeps on them. Leave a little space, you hear the squelch tail, and then after a second or two, the other guy can come in. Now, how do you interrupt? You simply put your call sign in. And if you've got an emergency, you say KE0OG emergency. And if the guys are decent at all, which most are, they'll let you in with the emergency. Okay. So, all the radios, all the Chinese radios, and a lot of the Japanese ones too, will put an EOT or end of transmission beep. Now, if you're on simplex, that might be a good idea because then the other person knows that you really are done with your transmission. Because on simplex, if it's full quieting channel, they can't really tell when you've keyed up. So anyway, hello, Dave and Augie's SHF and UHF antenna. I'm thinking of buying an IC905. Let's look at that on the ICOM page here. ICOM America, I think it is. ICOM America, okay. There we go. Okay, and products. Come on. Products. Amateur. Okay. Where'd it go? There's the 9700. Where's their 705? There it is, right there. 705. The 705, I believe, is only up through 70 centimeters. Now, if you get the, they call that a handheld? That's strange. Okay, if you look at the base stations and you look at the ICOM 9700, you can buy an option for it that will allow it to go up to 1200 megahertz. Okay, 1200 megahertz, which is microwave. It's in the microwave. You need it says a type N for that. I don't know how they really come all the time. Somebody who's got one tell me. But 1200 megahertz, you need an antenna. Now, there are two issues with that frequency. One, the antenna for it's about this tall. Now, I've got an antenna over here that I made to catch aircraft ADS-B, which is up to similar frequency, 1100 megahertz. And it's about that tall. And then I peeled back on the braid equally far. So I had created a coaxial dipole for it. And I did a video on how I made that. And that would work. And I use the LMR 400 for that, the best coax I've got, because at that frequency, coax is very lossy. Very lossy. So you're actually going to do best with that if you're in a portable environment where the distance between the transceiver and the antenna is quite short. It's quite short, like that maybe, in order for that thing to work properly. Now, an antenna is an antenna is an antenna. A dipole is a dipole is a dipole. A dipole like that will capture just as much voltage from the environment as an 80-meter full-length dipole will. It's just weird because the gain equation for antennas has a lambda in the denominator. I went through this in my engineering. And what that means is the higher in frequency you go, the smaller the antenna you need. And so Dish Network can get by with an 18-inch antenna, whereas the old S-band satellite things had these huge 8-foot, 6-foot dishes that were in the backyard. Each antenna worked just as well because there's a lambda in the denominator, and that's the wavelength, and as the wavelength goes down, the gain goes up. So very, very interesting how they did that. It's very interesting. We've got an 18-inch dish antenna, and it's got 3 feed horns on it looking at 3 satellites. Each of those satellites has a transmitter running on solar power that's about, are you ready for this? 50 watts. 50 watts. And that transmits all their channels at once. 50 watts. And then it hits yours, goes straight into an LNA, down converted, and then goes into the satellite receiver. It's actually down converted at the antenna. And you get beautiful clarity on your screen. And that's because the frequency is so high, that the wavelength is so tiny that antenna gives you just as much gain as, say, Arecibo at a low HF frequency. So it's really very interesting how this stuff works. Anyway, I see it's actually a 9700, and they make a 705. And it's the 9700 that goes all the way up to that microwave frequency. It doesn't normally, you have to buy an add-on for it. Okay. And the best way that those signals are arranged is by, setting up a schedule so that you can get on with people like that. There's a lot of people who like to tinker with microwaves, and they have their own contests every year, usually done from a mountaintop or something like that. And these guys, when propagation is good, when the air acts as a microwave waveguide, you can go really far. Okay. You've not covered antennas for SHF. Just did. Okay. Let me see if I can find that video. I'm going to go to studio here. Screen. Studio. This is set up for uploading videos. Okay, coaxial. Whoops, that's not spelled right. Coaxial dipole. Okay, it's Ask Dave number 276. It was a stay-at-home special from 2020, and it talked about building a coaxial sleeve microwave dipole. In this case for ADS-B, but you can do it for the 1.2 gigahertz ham band, yeah. So take a look at Ask Dave 276. 76, I think that's a 6, yeah. Okay, so let's go back to normal view. All right. Yes, I agree, Radio Bro, that local ham is wrong. Lieutenant Colonel Nicholson, thanks, Dave. Really learned a lot from you over the years. Take care. Thank you. 8 Balric says, good evening, Dave. David AC3HT, hello. Thanks for the live stream. Adds, says 73 or best wishes from AC3HT and adds $5 to the chat revenue. Thank you very much. James McDonough, all right, Dave, watching from England. Bertold Edmund, Victor 6, Papa Bravo Echo, hello from Pohnpei, Micronesia. Whew, long ways away, a good DX tonight. Mike Oswald, $10, and he's rolling on the floor laughing. Very good. All right, adds to the chat revenue. Alan Failer, hello Dave from Ohio, KB8RXY. Kevin Poff, hello Dave, KQ4FIP, on a flight from Charlotte back home to Music City. All right. Mike Oswald, here we go. Come on, let's give Dave a boost. And Gesundheit. Jarrett McAllister, hello from Elizabeth, Colorado. I think I know where you are. That's not far from a petrified forest. Am I thinking of the right place? And there's a company there called Bilal, B-I-L-A-L, that makes the isotron antennas, which are really, really weird looking things. It's so weird that I bought one with channel funds, 20 meter. And doggone if the thing didn't work. I was major surprised. It worked just fine, about as well as a dipole. And it's dinky. I mean, it's like literally about this big. So, Glenn Martin, hello from far west Missouri area, 32 degrees, 79% relative humidity. And let's see, Dave, people think very differently, have different skills and experiences. Oh boy, isn't that the case. You struggle with it, to others it is easy, and some they may never learn how to use a nano VNA. My concern, I like, for the new general, for everything to be point and shoot. If you get yourself an ICOM 705 and you take out the basic manual and you set everything to 0, so no preamp, no attenuator, just turn it on and use it. It works. And then, as you get more experience with the thing, you start to learn what all the buttons are for. And you get more and more used to it. Eventually, after several years, I would say for many close to 10, you will then get to the point where you'd like a better rig, like the 7610 or something like that. I do not recommend the 7610 for beginners because it's like learning how to fly by stepping into the cockpit of a 737. Let's see. I sent you a message on Patreon showing how to set up the Nano VNA for SWR in less than 2 minutes. And I watched that and I followed along with it. And I got to the SWR part, but I could not set the frequency limits because it starts at like 50 megahertz. And I want to start it at, say, 14 and go to 14,350 and see how the 20-meter band does on my beam. And that's where I got lost, was I went through menu after menu after menu after menu, touching all sorts of things on the touch screen. Could never get to it. So that's where I need help now, is setting the limits, the frequency limits. Okay, Edson Brusk sends R762. Okay, Real? I'm not sure. I learned a lot from your videos. Thanks, Dave. You're great from willing to share your knowledge. 73 from Papa Uniform 5. Bravo Romeo Uniform. Edson, thank you very much. Thank you very much for passing that along. I appreciate that. Christopher Andrews, they are great tools for homebrew antennas and balance. Oh yeah, absolutely, they are. Hello from Manila, and I'm trying to hook up Anderson power poles, connectors, and was wondering if it is advisable. Trying to hook up Anderson. If you're looking at Anderson power pole connectors, I do have a video on that. Oops, Anderson. Using Anderson and its ON here. There's several videos. Using Anderson power pole connectors, installing them, using them. Okay, so there's 4 videos in there on Anderson power pole connectors. One is ASDA 44, another is 254, another is 755, and 765. No, that says 7677. Oh, I remember what happened there. We put it up on Patreon first. Okay, so we'll go back to our normal view here. And so I like the Anderson power pole connectors for power connections because then I can cross-connect anything. But it does take a little to put them up. And if you're going to use thin wire like this wire right here in a power pole connector, you're not only going to want to crimp it, but you're going to want to come back in and drop a little solder on top of that too, because otherwise it'll pull out. So GOFVT, I was one of the defenders of the Nano VNA, but for outdoor antenna work, I find the MFJ more convenient and easier to use. A problem to a minority of users is that the Nano VNAs lack dynamic range. The Nano VNA professes to do what a very expensive inexpensive, tens of thousands of dollars piece of lab equipment will do, and do it for 50 bucks or whatever they've gone up to now. And it can do a lot of that stuff, but not all of it. It has a nifty computer interface, and people have come up with absolutely wonderful diagrams using those things. So once I get this figured out on how to set the upper and lower limits on the frequency, which is something you have to do like on the Rig Expert, you have to tell it what frequency band to look at, and then it'll go look at that. It's got a lot of the ham bands just set up. You can just punch the button. And the little mini 1300 analyzer that I just use happens to be a vector network analyzer. I don't know if it's the Nano VNA or if they got something else in there. I wouldn't be surprised if they build it around the Nano VNA. But the menu on the front screen, it's all there. Want SWR? Punch. You want a graph of SWR? Punch. You want graph of SWR across all the different bands? Punch. It's all right there. You want to test the capacitance, test an inductance, all these different little things that you can do with these things is just right there for you. And it will do the true nano VNA kind of stuff where you can like put a coiled trap for an antenna, and you can feed in from one side and bring the other in the other side and see a graph of just exactly what that trap is doing for you. And so it's a very handy tool, very handy tool. My issue with them is user friendliness. In the hands of a ham who's been a ham for 5 or 10 years, yeah, dig through the manual, figure out how it works. But for somebody who just got his general and wants to put up his first HF antenna, it's just too much. It's just too much. So that's been my hesitancy with the Nano VNA. Okay, let's see. From the defenders, we once had someone call onto a net on HF, and two of the group immediately identified the radio they were using via its end tone. I was impressed. It was a Coden Mobile. William Myers, KE0OG, my Dave and Oli Augies. Glenn Martin, breathe is the chemical term for containers taking in and expelling air. Bottles of chemicals do not do this. Well, I got to tell you, this box that was on our radar had a great big fat seal on it and was certainly put on properly according to the tech orders. It did not leak. That was not the problem. It should have leaked. I had them put a little 1/8-inch hole in the bottom. Never had the problem again. So, yeah, breathing. Larry Fields. Also, where can I locate used ICOM parts? Oh, good luck. I had somebody come to me with a pretty sad sob story about a radio that he couldn't get fixed. It was a Yaesu, I think. There just really aren't people around who make it a business of fixing these Japanese radios. You know, all of the boards in them are surface mount components. Now, like for the ICOM 7300, I've got a big stack of schematics. So you know exactly what the different boards are supposed to do. And if you really can dig into it. By the way, one of the pieces of things that's being sent to me is a microscope. I have a microscope right here that's designed specifically for surface mount components. It's a very good microscope. It's all analog. But this company has a big microscope with like a full HD imaging chip, and then it has a 10-inch screen on the top of it. And so you look at it by what's in the screen. And it has two lights you can adjust, Plus it has lights coming straight down at it, so you can get just the right angle of light. And the idea being that those would be perfect for doing maintenance on these things. Now what you can do is what people have done. If you can narrow it down to the board where the issue is, go in, look at the board very carefully under a magnifying glass, under a microscope, to see if anything is blown out. Because you know when you blow it out, you let the magic smoke out, it's going to leave a trace. There's going to be a burn mark on the circuit. And if you can go in there and you're good with surface mount components and you have a microscope, you can take the old part out, put a new part in. It can be done. I do not recommend it for the faint of heart, because it's quite something. I got a radio from QRP Labs. In fact, it was a radio I was just showing you. This one, right here. This has on it a very tiny number of surface mount parts. And it wasn't working. And I described the symptoms in a live stream or something. And it finally came down to, looking at it under the microscope, there was a solder ball that had fallen between two pins of a surface mount component. So I got like the tip of a needle, which was huge compared to the solder ball, went down in there and pushed that solder ball out of place. Lo and behold, it started working fine. So it can be done. But yeah, this is a real issue. People who have old equipment, by old I mean 10-year-old, 20-year-old, in getting it repaired. There just aren't people who do that anymore. You could get yourself, if you read Electric Radio, I just brought the latest edition in here. I don't know what I did with it. There are people who advertise that they'll repair old radios for you. But I don't see anybody advertising that they'll repair Yaesus or Icons or Kenwoods. So I'm sorry, Larry, I don't know. Often they can be repaired. Okay, let's see, make sure. Okay, Dwayne says, KE0OG, make sure to hit the like for this live stream. Yes, please. A GOFVT capture area of a half-wave dipole is 0.131 times lambda squared. I don't know. Now, I have tried to find in my old college textbooks, which are all up there, the equation for the gain equation for antenna area and stuff like that. Now, see, what you've got here is that the capture area is proportional to lambda squared, which as the wavelength goes down, the capture area goes down. But the capture area of a 20-meter dipole will capture just as much energy as the capture area for an 80-meter dipole, because a dipole's a dipole's a dipole. And I know that may seem absolutely counterintuitive, but it is not. If you put a transmitter with a 75% effective signal at some distance away, and it transmits the identical amount of power on 40 meters and 20 meters. You can put up a 40-meter antenna and a 20-meter antenna, and they will give you the same output. So the reason for that is this idea that of frequency. A dipole is a half-wave antenna, and the half-wave antenna will have an appropriate capture area. I once went through the math of saying, okay, if there's an isotropic antenna in, say, Zanzibar, and I'm sitting here in America, you've only got so much power per square foot. Only got so much power per square foot, right? If you're putting out 100 watts, there's only 100 watts to be had over all the world. So it's going to be some femtowatt or something that you pick up over here. And I tried to do that, and it didn't work. It didn't work because there's a lambda in the denominator for antenna gain. Now, antenna gain is different from capture area, but antenna gain. The fact is that, as I mentioned, a little dish antenna like this can receive a signal that's just as good with the same signal to noise ratio as one of those great big 6-foot dishes that people used to stick in their backyards that were on a lower frequency. So it's just the fun of the way electromagnetic waves work. There's no point in building an 80-meter parabola. You could. It'd be about the size of Arecibo. Okay. You could. It becomes easier and more realistic to build parabolas for microwave frequencies, like 1200 megahertz, 12 gigahertz. Even at 70 centimeters, you're better off with a Yagi, because a Yagi is easier to manipulate than trying to build a parabola and a single feed element that would give the same gain as a 10-element Yagi. So there's a cutoff point there where you want to start using parabolas with a single element in the feed. And you've got waveguide, which is obviously guiding a wave because there's no wire down the middle of it. It's just a tube. And it can be circular, it can be rectangular. And we had to go through all of this multi-mode waveguide, single mode waveguide, all this kind of stuff. And then at the very end of it, as it points toward the antenna, there's a little tiny piece of metal sticking up. And you know what that is? It's a dipole. And what's coming in there excites that dipole, which then spreads the energy out over the entire parabola. Now you do get some spillover. Okay, those are called side lobes. You do get some spillover. And you want to make it, some of the ones that want to be really efficient actually make the parabola too big so that everything shot at it is reflected out in one direction. One of the biggest problems at microwave is aiming the antenna. And if you don't feed a parabola in the middle, you feed a parabola in the middle, it's real easy to aim. But if you feed it at the bottom, it goes out this way, and it's very difficult to aim. So that gets into a lot of fun too, because when you get, 40 dB gain is achievable with a parabola. 40 dBs. Would you like to have a Yagi with 40 dB of gain? But there are no side lobes. Like today, I was on the radio and I heard somebody calling CQ. And he said he was in a certain park. So he was doing POTA. And so I kept talking to him, trying to find out what state he was in so I could aim the beam. So it turned out he was off the back of the beam. So I got the beam swung around and by hex beam. And I didn't have to use extra power or anything. It just came through fine. And I talked to another couple people today too. That was fun. Okay. Let's see. New Ham using a kilowatt TS130S. That's Kevin Poff. Endo second or tooth. Endo tooth. Okay, endodontics tooth. Hello to all from KG4HVQ, who's got to be a dentist, in North Alabama. Larry Fields has been playing with AMSAT satellite. I have an old satellite dish. Can I use this for hitting the birds? Probably not, because the beam is going to be 6 feet in diameter. So the actual intensity, the energy density at any given point is going to be a whale of a lot less. So, GOFET says, P.S. I believe the 9700 covers 23 centimeters as standard. Okay, then that may be a change from when it first came out. And I don't have one. I've never played with one. They're very much like the 7300. It was designed to be a complement to the 7300, and it costs as much as the 7300 and covers 3 bands. It does not cover 220. There's a 900 megahertz band in there it does not cover. And so I've never really thought that it was a very flexible radio. But be that as it may. Okay, Colin in VK land. Good day, y'all. Benjamin Otto, Legacy Technology. Yes. Bob Horsch. I'm having a problem with legacy technology with my aircraft. I'm down to 2 parts I'm missing. It's the fork over the front wheel and the rim. And you'd think that wouldn't be too hard to come up with. Well, the airplane manufacturer is the source for this. It's RANS, is the source for this, and their response is, we'll get to it when we get to it. But gee, thanks, guys. You know, this is one of your airplanes. Granted, it's a legacy airplane, but I'd rather fly it than see it sit in a hangar. It's been 4 months now. So I'm trying to light a fire under them. And you see, any tips or thoughts about remote operation of a station over the internet? Sure, go ahead. You know, there's nothing wrong with that. MFJ makes a little device. You can do it. The newer ICOM radios will do basically direct connect. The MFJ product makes it a little easier. That's this thing. No, not that. This one. You can remember it. It's an MFJ 1234. Okay, and it's got all kinds of connections. You can tell it's a Raspberry Pi. And all different ways so that this thing is uniform for its adaptation to lots of different receivers. It will not put your waterfall over the internet, but you can use this if you put, like for the ICOM 7300, you plug in the USB from the 7300, you plug in the Ethernet, and that's all the cables you need to put in, and this will work. Okay, so this has been out a few years now. Again, it's the MFJ 1234. Now, there are lots of other ways you can do it too. And like I said, the newer ICOMs and so on, you can connect direct to the internet. And then you use software on the other end that will actually show you the waterfall. Okay. Hitting the birds. I'm sorry, Larry, I completely misinterpreted that. I thought you were trying to create a bird killer, like you've got a crow problem on a farm or something. No, the birds are the satellites. Duh! Okay. Been playing with the AMSAT satellite. I have old satellite dish. Can I use this for hitting the birds? Yes. You can. The ones that are higher in frequency. If you're going to go like one that's on 440 up, 2 meters down, or something like that. By the way, they make antennas that you can handhold to do that. You're probably better off with Yagis, but if you're getting into microwave, you can certainly use a dish antenna. Although I think some of the satellites, I've got a book from AMSAT here somewhere. It tells you how to do all that. I picked it up at Dayton. I have to pull it out. But there are lots of things you can do. Okay, good evening, Dave Newham here. Welcome to the fraternity, sorority, whatever. It's a wonderful organization. KE0OG from Ohio, using an Anytone 878 UV2+, playing in DMR while in studying mode, getting my general at the end of April. And if you are a member of the league, and I trust you are, a member of the ARRL, if you go to learn.arrl.org, you can find my general training videos. They match the general book section for section. So they should be a good adjunct to your studying. And good luck with that, and welcome aboard. And that Anytone should give you good luck. You might want to create an outdoor antenna or get a mag mount for your car roof or something. And DMR's got a lot to play with. There's a lot there. Rick Easton, go here and find one of the maps that work. Rick Easton. Does he reappear down here somewhere? No. If you have something to send me, send it to askdave@arrl.org. You don't have to be a member of the league. Ask Dave, all one word, ASKDAVE @arrl.org. Please send it that way. Don't call. Don't text. Send the email, because then I can get to the emails when I can get to the emails. Now, another thing you can do that I will tell you that you can do if you want, and a lot of people would prefer to do this. I've had several people do this. Send me a letter. You know, paper, envelopes, stamps. Send me a letter to Dave Casler, KE0OG, P.O. Box 98. P.O. Box 98, Ridgway, Colorado. That's R-I-D-G, no E, W-A-Y. R-I-D-G-W-A-Y. Colorado, 81432. That will get to me. And it comes in along with all the emails, or the entries for the drawing. But I open every envelope and check to see whether it's just an entry or whether there's a letter in there or something like that. I got a really nice letter from somebody the other day just saying how much he enjoyed the programs, and I put that in the pile of letters that I keep, and I appreciate that. Go here and find one of the maps that work. Rick, I'm not quite sure. I'm not seeing another one. Leo Gustafson, hello Dave and all Augies, KK7CLY dropping by. Optical Man Jeff, KE0KRO, is adding $15. Says, thanks Dave for all the knowledge that you share with us every week. I think we all need to nominate you for Elmer of the Year. Thank you. That is an ARRL competition. That would be very nice. Thank you. The chat revenue is up to $31.46. The odd amount is from that Pew station that dropped something in there in a different currency. Larry Fields, thanks. The solder was what I heard, but the last time I tried to do it, I goofed it up, so we'll look into it more. Okay, you got to be careful on those Anderson power pole, the little clips. You want to crimp them, okay, And then on the front of it, between the part that sticks in and the part where the wire is, in front of that, put a little tiny bit of solder. If you put it anywhere on the sides, you won't be able to get the stupid thing to go into the connector. And ask me how I know. So that's something you can do. JT6188, I use a VNA for a resource like my MFJ 269. If you realize that it's not a $30,000 test unit, you're in good hands, yes. Darren Poole, Nano VNA was designed to work ranging from 50 kilohertz to 300 megahertz, according to the vendor. There are lots of vendors. Let's see. It just jumped up on me, so. Okay, here we go. Yeah, Nano VNA was designed to work ranging from 50 kilohertz to 300 megahertz. The problem is the HF bands go from 1.8 megahertz up to 30 megahertz, which is a tiny fraction of that default band. And so I want to set the lower and upper bounds to be like I want to look at a single band or something like that. So now there are lots of vendors. The thing is, it's open source. So anybody can make one. And I believe the people who head the project have got a list of recommended sources, but I'd like to know the URL for who it is that actually sits atop that boiling tea kettle there, because they have some recommended. Let's see, 20 meters sounds a lot cleaner than 40 meters. Is 80 meters even noisier than 40 meters? Absolutely. Is 10 meters even cleaner than 20? Oh, yes. And that will go on up. You will get to the point where by the time you get up to the microwave band, the only noise is additive white Gaussian noise, which is thermal noise. And this is the point where it pays to supercool your parametric amplifier that's at the feed point so that your noise figure will be very low. Now, my Tentec up there for HF, it very proudly says that the noise figure is 11 dB. Now, microwave, that'd be an inexcusable noise figure, but at HF, that's pretty good because the band noise is higher than that. Now, I actually measured, you can measure noise figure on these things, and I measured it at 13, so I think they were off 2 dB. Maybe they were copying from an older manual. But the noise figure is a measure of how much noise the amplifier, the front-end amplifier, adds to the additive white Gaussian noise already there. So if you've got a signal that's 1 dB above the noise floor, and you have a very nice microwave receiver that has a noise figure of half a dB, you'll still see that signal. But if your noise figure is 2 dB, you won't even be able to tell it's there unless you do some strange and unnatural things regarding modulating that signal, coding it, and so on. I was starting work on a PhD in California before I moved up here to Colorado, and it was on this information theory. It's like, how do we get a signal from Pluto to Earth? The answer is they convolutionally encode it. The 7-unit convolutional code. In the original days of the probe, it took about all the computer technology they had to deconvolve that coding, and they used trellis decoding. And they could go about 7 steps in the trellis. Well, now with modern computers, they can go hundreds of steps in the trellis. Now what the trellis will do is just paths that cross each other. It looks like a trellis for flowers. And you get to this point in the trellis and say, well, 38% it's a 1. Okay, 62% it's a 0. And then you got one over here, and you got one over here, and one over here. And there's a process for adding these up and coming up with a probability estimate that it's a 1 or a 0. And then as you start stringing these words together, you can use that probability and say, wait a minute, I got a 70% probability that this is a 1. But if I make it a 0, this code string makes more sense. Okay, they can do things like that. And you can have signals that are so low in the noise you can't tell they're there. And whenever you use FT8, you're doing something very similar. It's the coding that gets the stuff through. Signals you can't even hear will show up on your diagram because the system is pulling that out of the noise by looking for specific things at specific times. And it's absolutely fascinating. Okay, let's see here. Yeah, the noise that we mostly notice on HF is atmospheric noise, sometimes just called spherics, S-F-E-R-I-C-S, something like that. And it is mostly lightning strikes around the world. At any given time on Earth, there's lightning happening. And that lightning, the electromagnetic pulse from the lightning, goes ricocheting all around the ionosphere. And the higher you go in frequency, the less of this noise you have. Now, on 80 meters, you've got, and 160 meters, you've got this problem of the D layer, and you get absorption. It's interesting to me, the verb is absorb, ending with a B, and then the other form of it, absorption, has a P in it instead of a B. Go figure, it's English. So anyway, that's why the lower bands are the way they are. 20 meters is a nice inflection point where you have less noise and still really good signals. As you get up to 10 meters, there really isn't that much noise. Now, if you add a preamp with your HF amp, on 80, 40, 30, and even 20, if you add a preamp, it will make everything louder, right? Including the noise. And it will add noise. It will add noise. So don't use your preamp below about 17 meters. Now 17 and on up, you can start thinking about using preamps because the atmospheric noise starts to go away. They're fairly low noise preamps that they've got in there these days, but if you get into a place where there's no atmospheric noise, the preamp can really help you pull the signal out of the mud. Okay? It's interesting because attenuators are resistive, and resistors create noise, but only at very, microwave frequencies and stuff like that. It's a fascinating subject. Okay, the Smoking Ape did a good basic intro on the Nano VNA. Included setting the range in SWR. I was able to verify my new homemade quarter wave ground plane with SWR 1.1 to 1. Very good. I'll have to look at his stuff. He's a nice guy. Yeah, because I now know how to get it to SWR, but I don't know how to set the range, so I'll have to look at that. Dwayne KE0OG VNX says, to be fair, I am a computer Syed Sky. Yeah, my daughter is too. She makes more money than I ever did, I think. Harry Rundle. Hello, Dave from Harry, AC3EK. Late sign in from Oakley, Maryland. Been on 20 meters, hot conditions, working into Europe, FT8. Earlier this week, worked long path into western Siberia. The vertical and 7300 is great. Very good, very good. Yeah, I was listening on 6 meters today, and just looking at different bands. And I couldn't hear anything on the band except, well, I couldn't even hear the FT8. 10 meters, I could hear the FT8. The band was kind of closed. Okay. I have a 706 Mark II-G that's just quit on me. It kept powering on and off, then died. Can't find the issue with it. Also a 706 that's lost audio amp stages in the receiver, still trying to figure out. Good luck. Good luck. Since it's broken, okay, I always use this as an excuse. It's broken, therefore it doesn't matter if I break it while I take it apart. I did that with a little CD player. Remember when you used to put those in your pocket while you went jogging? Now you get it off your iPhone, but then it was a CD player. CD player had stopped working. And so I says, great, I can take it apart and see what's inside. And I found the problem and fixed it and put it together. And it worked fine for several more months. And then it had the same problem. So I took it apart, fixed it again. I don't remember whatever happened to that thing, but I fixed it twice. I had a monitor, an older monitor like this. The power would die on it. And you could sort of get in the back and see what was going on. And it turned out the plug, the 3-element thing that you plug the power cord into on the back, had broken the solder joint. So I resoldered it, monitor came back up. Did the same thing again, broke the same solder joint. So this time I connected a little piece of wire from the plug loop over to where it hit on the circuit board. So if it vibrated again, it wouldn't matter. And worked ever since. In fact, I think that's the one my assistant uses. Okay, boat anchor radios had a lot of through-hole components. Yes, circuit diagrams were available. Circuit diagrams are available for the new stuff too. What's this? ICOM radio. And let's see if I can pull these out of here. Or maybe they're just on the CD. Oh, that's in the wrong place. Okay, they're just on the CD. But there are circuit diagrams available, not just of the wiring between the boards, but each individual board. Okay. On the Mark II, we pulled it open and did almost everything to it as the display was turning brown, and it was nearly complete, but when we turned it back on, the display will not show the frequency. Oh, don't you hate that? Oh, Larry, thanks, he says. Natalie Batista, KK4FLA. Hello, Dave. I'd like to bring ham radio to young people. I figured that a presentation about ham radio to boys and Girl Scouts would be productive. Any suggestions from the Augies? You know, I just had my hands on it today. QST. This goes back a ways. Let's see if I can find what page it's on. I did an article in here about the Boulder Amateur Radio Club Junior Division, 49, page 49 in the September 1997 issue. And yes, you can get that on the ARRL website. It was page 49. Here it is, Bart Juniors, Boulder Amateur Radio Club Juniors. I wrote this article. It says an auxiliary youth club success story that you can duplicate. And there's this old guy helping people make an antenna. And the thing was put together by Ellie Van Winkle, who has become a silent key. And that is my daughter running the weekly net. She was quite a bit younger at the time. She's in her 30s now. Here's Mike Ballback, who's a game developer working on something there. And this article, it's 2 pages in here, will tell you how a youth club works and what it takes to make it work. And it works for grown-up clubs too. Oh my, we're over time. Oh dear, I'm sorry. I've been rambling tonight. Something terrible. I've just been rambling. Anyway, there's a club in somewhere around Pomona, within 10 miles of Pomona, I think. This guy formed a club there because he couldn't find a club he liked. It was a new ham. So he started his own club. And he got all of his friends to become hams. And they do things every week. And he keeps them busy. They go on tours. You know, we took the kids down one time on a tour of the radio equipment at Denver International Airport. They were willing to have us. And, oh, we did all kinds of things. The kids really loved foxhounds. And the idea was that it was a kids' club. The kids were elected as officers. These are middle school and high school kids. And they come voluntarily. Now, what Ellie did every week was she went down her list and called everybody and says, are you going to be here this week? Yes or no, I need to know, so I get the right refreshments or whatever. But this was the way she reminded people to come. She had about 10 Elmers working with her at any given time. I was one of them. I helped her for 10 years. And that club is still running. Even though Ellie and Rip have both died, what they've done has been taken over by some very enthusiastic people, and they're still running that club. And yes, there is a way you can do it, and you have to have somebody at the helm who's got the get up and go to really make it work. Because if you just get it up and think it'll run by its own power, it won't. Not with kids. So you've got to have the adults. And there are methods that are all covered in that article, how to do it. And I was part of it, so I could write about what I knew about. Okay, we have run out of time. Are there any good kits for making your own 2-meter transceivers a personal education project? I don't think so. I've seen kits that make a 2-meter transmitter for I'm forgetting the name of the direction thing. Okay. Work for box chip and sell DMR. Good kits. 7,300 for $9.99. A good deal now. Yes, it is. It's a very good deal. Yeah. Oh, that's always a problem. You get something and then the nano VNA can easily do exactly what you want. Right. Right. Yeah, if you say so. I really tried hard today to find out how to set those limits and couldn't. I only have a master's in electrical engineering. Maybe I needed a PhD. Okay. My credit card was rejected for a linear power supply. Somebody's got a 991 for sale. It's a nice radio. It's the last generation of Jesus. Okay, we are overtime. I apologize for taking you overtime. We made it up to $31.46 chat revenue. We topped out at 136 people. Thank you for spending your Thursday evening with me. I think the numbers are down because, we've done the time change now. And it's 7 o'clock Mountain Time, whether it's, so that meant, it's earlier now than it is before. And it's almost 8:30. I apologize. Thank you very, very much. Sent you another video about the Nano VNA Freaks on Patreon. I will take a look at that. And thank you guys so much. You guys mean so much to me. I mean, I do what I do because of you guys. And your feedback to me is so important. Makes me just really want to keep doing this. So, until we next meet, 73.